This video lesson is for Unit 1, Ratios, Lesson 1, entitled, What is a Ratio? The learning target for this lesson is I can understand the concept of a ratio, and the standard is 6.RP.1. We're going to begin by talking about what a ratio is. A ratio is a comparison of two numbers, and a ratio can be written in three different ways. I'm going to show you the three ways we can write a ratio. I'm going to start with the ratio of 3 to 5. So first of all, if we write 3 first, put a colon, and 5, that is the first way to write the ratio of 3 to 5. We can also write it with the word 2 in between, so 3 to 5, and this is how we say the ratios, 3 to 5. And then finally we can write it as a fraction. 3 would be our numerator, and 5 would be our denominator. Here we're going to use the pictures below to practice writing ratios. First one we're going to do is teeth to no teeth. Since teeth comes first, we have to count those first. So there are 1, 2, 3, 4, 5, 6, 7, 8, and 9 that have teeth showing. So that is the first number that I'm going to write. 9 with teeth. And no teeth, well, there's 24 total because we have 8 in a row and 3 rows. 8 times 3 is 24. If I subtract 9 from 24, I would have 15 left. So my ratio is 9/15. Well, we always need to write our ratios in simplest form. So that means we have to find a factor that we can divide both 9 and 15 by. We're looking for the greatest common factor. That greatest common factor is 3. So if I divide them both by 3, we have 9 divided by 3, and that will give us 3. And then 15 divided by 3 would be 5. So we have a ratio of 3 to 5. Next one, smiles to the total. Well, there are 4 that have smiles, and altogether we said there were 24. So once again, we have to find a number that we can divide, because I know this isn't in simplest form because they're both even numbers. 4 and 24, the greatest common factor would be 4. So if we divide them both by 4, 4 divided by 4 is 1, and 24 divided by 4 is 6. So our reduced ratio is 1 to 6. Tongue to total. There are 4 of these faces that have a tongue sticking out. And once again, the total is 24. And if you'll notice, this is the exact same ratio as we started with here. So I know I can divide them both by 4, giving me a reduced ratio of 1 to 6. Angry to smiles. There are 12 that are angry, and there are 4 that are smiling. 4 and 12 have a greatest common factor of 4, so if you divide both of those numbers by 4, we're going to have a reduced ratio of 3 to 1. The next one is big eyes to teeth. There are 12 that have big eyes, and there are 9 that have teeth showing. We can divide both 12 and 9. The greatest common factor would be 3. So 12 divided by 3 would be 4, and 9 divided by 3 would be 3. So our ratio is 4 to 3. Smiles to tongue. There are 4 that are smiling, and 4 that have their tongue out. Gives me a ratio of 4 to 4. We can divide both of those by 4, making it a ratio of 1 to 1. So this is meaning for every 1 that is smiling, 1 has their tongue out. The last one, silly face to angry. There are 12 that have a silly face. There are 12 that are angry. We can divide them both by 12, giving us a reduced ratio of 1 to 1. And the last one, tiny eyes to no smile. There are 10 that have tiny eyes, and there are 20 of them that are not smiling. We can divide them both by 10, and that will give us a ratio of 1 to 2. Here it says, in the lunchroom there are 100 chocolate milk cartons at lunch. When lunch is over, 88 had been purchased. The question, what is the ratio of the number of milk cartons purchased to the total number of milk cartons? So here, first of all, we start with the number of milk cartons purchased. That'll be the first number in our ratio. That's 88. And then the total number, it says, was 100. We got to find the greatest common factor of 88 and 100, which would be 4. So if we divide both 88 and 100 by 4, we'd have a reduced ratio of 22 to 25. On this problem, it says, what is the ratio of the number of milk cartons remaining to the number of milk cartons purchased? Well, there were 100 milk cartons to begin with. 88 were purchased, so if you subtract 88 from 100, we would have 12. So that is our first number, and we're comparing that to the number of milk cartons purchased, and that was 88. So we have 12 88ths. Once again, the greatest common factor of 12 and 88 is 4, so if I divide them both by 4, I'm going to have 3 22nds. The ratio of 3 to 22. In this example, it says, using your pencil and paperclip, spin the spinner 20 times, mark your results in the tally chart below. Well, obviously I cannot spin a paperclip on here, so I just randomly filled in numbers. I said that it landed on 1 2 times, it landed on 2 5 times, landed on 3 1 time, landed on 4 4 times, landed on the 5 5 times, and it landed on 6 3 times. I add those all up and I would have 20 altogether. So now it says, describe a relationship based on your spinning in which the ratio is 1 to 4. So if I look back up on my numbers, the 1 landed on the number 3 1 time and it landed on the number 4 4 times. So that tells me that if you landed on the number 3 1 time, since that is our 1 right there, and you landed on the number 4 4 times, that would give us that ratio of 1 to 4. Our next question says, what would need to happen to create a ratio of 3 to 1? So 3 is our first number, and 1 is our second number that we would spin. So that means that we would need to land on the first number 3 times and land on the second number 1 time. Therefore, it would create the ratio of 3 to 1. Landing on the first number 3 times, landing on the second number 1 time. In this example, we are asked to create 4 different ratios related to the experiment above. So we can just choose any one of these numbers, put 1 first, put 1 second, and we have our ratio. So I'll just randomly do this. So if I do a ratio of 5 to 2, that could either mean that I rolled the 5 times or the 2 5 times, and the only one that is 2 means I rolled the 1 2 times. Another one could be 3 to 1, and that would mean that I rolled the 6 3 times and the 3 1 time. Randomly, we can do another one. If we do 1 to 2, that would mean that I rolled the 3 first and then the 1 second. And one more. I could do 3 to 2, which means I rolled the 6 first and the 1 second. This is something we have already talked about, but it's super important. It says ratios can be, and we fill in the blank here, simplified. Remember, when we write our ratios, we need to simplify them into lowest terms or simplest form. The last thing we're going to do on this lesson is practice simplifying ratios. We're going to simplify the ratios below. The ratio 3 to 6, we can divide both 3 and 6 by 3, giving us a ratio of 1 to 2. 3 divided by 3 is 1. 6 divided by 3 is 2. 7 and 21, we can divide both of those by 7, giving us a ratio. 7 divided by 7 is 1. 21 divided by 7 would be 3, a ratio of 1 to 3. 18 and 45 can both be divided by greatest common factor of 9. 18 divided by 9 would be 2, and 45 divided by 9 would be 5. So we have a ratio of 2 to 5. 100 to 60, we can divide them both by 20. 100 divided by 20 would be 5, and 60 divided by 20 would be 3. So we have a reduced fraction of 5 to 3. 5 and 25 can both be divided by 5. 5 divided by 5 would be 1. 25 divided by 5 would be 5. So we have a ratio of 1 to 5. 33 and 21 have a greatest common factor of 3. 33 divided by 3 would be 11. And 21 divided by 3 would be 7. The ratio is 11 to 7. If we flipped it around and make it 7-11, I'd be getting me a Slurpee. 4 and 13 don't have any common factors except for 1, so it stays 4 to 13. And our last one, 20 and 65, can both be divided by 5. 20 divided by 5 would be 4, and 65 divided by 5 would be 13. So we have a reduced ratio of 4 to 13. And that brings us to the end of this lesson. I hope now that you can say that you can understand the concept of a ratio.